Hi, Assalamualaikum. My name is Muhammad HAKIM by Muhammad SHAHRUL, and my number metric is 33DCE21F1073.
Hi, my name is Muhammad Faris bin Cik Muhammad Nurli and my matrix number is 33DCE21F1055.
And today we're going to present about Izod impact test. So the objective of Izod impact test is to find the impact resistance of mild steel and cast iron. So the apparatus used is impact testing machine. So step 1 for to do Izod impact test is select the Izod test specimen. So first we select the cast iron. So as we're gonna see, the characteristic of cast iron is the length is 74.72 millimeter and the breadth 9.6 millimeter. The depth is 9.64 millimeter and the depth of notch D is 5 millimeter. So next, for the step 2, the test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. So the loss of energy due to friction, we got 4 joules. And then for step 3, the Izod test specimen as per Indian standard IS 3766 1977 is placed in position. So for trial 1, this is as we can see the radius of curvature of striking edge and the test piece, and as we can see the striking head, the angle tip of striker, the direction of impact, angle between underside of striker and face of test piece, and the support. So for the step 4, the pendulum is released and the hammer strike against the specimen, breaks it and swing further than the observation is not down. And then the total loss of energy during transit of hammer, we got 5 joule, and energy for failure of specimen, we got 1 joule. So the observation for trial 1, initial energy of the hammer, we got 164 joule, average loss of energy due to friction, we got 4 joules, total loss of energy during transit of hammer, 5 joules, and energy for failure of specimen or impact value, we got 1 joule.
Okay, trial 2. For step 3, the Izod test specimen as per Indian standards IS 3766-1977 is placed in position. Selected specimen is cast iron and length is 74.72 millimeter. Breadth B is 9.6 millimeter. Depth D is 9.64 millimeter. Depth of notch D is 5 millimeter. Okay, step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. So, the total loss of energy during transit of hammer is ET equal 4 joule, and the energy for failure of specimen is equal ET minus EF equal 0 joule. And the observation for trial 2 is initial energy of the hammer is equal to 164 joules, and the average loss of energy due to friction EF is equal 4 joule, and total loss of energy ET during transit of hammer is equal to 4 joule. And lastly, energy for failure of specimen is equal Ku, or impact value is equal to ET minus EF equal 0 joule.
So the Izod test specimen for trial 3, the selected specimen cast iron. So we got the length 75.9 millimeter, the breadth we got 9.6 millimeter, and the depth we got 9.92 millimeter, and the depth of notch D we got 5 millimeter. Okay, and then we proceed to the step 4. The pendulum is released and the hammer strikes against the specimen, breaks it, and swings further than observation is knocked down. And then for the trial T and for trial for trial 3, the total loss of energy during transit of hammer we got 5 joule, and energy for failure of specimen we got 1 joule. And then the observation of trial 1 to 3, we got a loss of energy due to friction. For trial 1 we got 4, and then for trial 2 we got 4, and then for trial 3 also we got 4. So the next, for total loss of energy during the transit of hammer, for trial 1 we got 5, and then for trial 2 we got 4 joule, and then the trial 3 we got 5 joule. And then we proceed to energy for failure of specimen or impact value. For trial 1 we got 1 joule, and then for trial 2 we got 0, and then trial 3 we got 1 joule. And average energy for failure of specimen we got 0.67 joule.
Okay, for second part of Izod impact test, first select the Izod test specimen and we select the mic steel. For mic steel, the length L is 75.3 millimeter and breadth B is 9.3 millimeter. Depth D is 9.32 millimeter, and lastly, depth of notch D is 5.6 millimeter. For step 2, test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. So we got loss of energy due to friction, EF is equal to joule. Okay. Trial 1 for step 3. The Izod test specimen as per Indian standards IS 3766-1977 is placed in position. So this is angle of tip of striker, this is test piece, and this is striking height, direction of impact, angle between underside of striker and face of test piece, and lastly this is support. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. Okay, so we got total loss of energy during transit of hammer ET is equal 48 joule, and the energy for failure of specimen is equal ET minus EF equal 46 joule, and the observation is initial energy of the hammer is equal 164 joule. Average loss of energy due to friction EF is equal to joule. Total loss of energy ET during transit of hammer is equal to 48 joule. And lastly, energy for failure of specimen is equal KU or impact value or is equal ET minus EF. equal 46 joule.
Okay, for the Izod impact test for trial 2 using the mic steel. So we got the length of the mic steel, we got 77mm, and the breadth B we got 9.52mm, and the depth B we got 9.52mm, and the depth of notch D we got 4mm. And then we repeat the step 4 for the trial 2. So the pendulum is released, the hammer strike against the specimen, breaks and swing for the observation is knocked down. And then for trial 2, we got total loss of energy during transit of hammer is 44 joule, and energy for failure of specimen, we got 42 joule. And the observation for trial 2, the initial energy of the hammer, we got 164 joule, average loss of energy due to friction, 2 joule, total loss of energy during transit of hammer, we got 44 joule, and energy for failure of specimen or impact value, we got 42 joule. And then for the step 3, and then we repeat step 3 for trial 3. We use the mic steel length 76.6mm and the breadth B 9.42mm and the depth D 9.4mm and the depth of notch D 4mm. And then we repeat the step 4 to do the trial 3. So as usual, the pendulum is released, the hammer strike against the specimen, breaks it and swing further than the observation is knocked down. And then for trial 3, we got the test piece was not broken by striking energy of the testing machine. So the impact value obtained is indefinite. So the observation for all trial, we got first one, for the loss of energy due to friction, for trial 1 we got 2 joule, for the trial 2 we got 2 joule, and the trial 3 we also got a 2 joule. And the total loss of energy during the transit of hammer, for trial 1 we got 48 joule, and for trial 2 we got 44 joule, and for trial 3 we got no information. And then lastly, the energy for failure of specimen or impact value. For trial 1, we got 46 joule, and then for trial 2 we got 42 joule, and the trial 3 we not got any information because the specimen are not broken and indefinite. So the average energy for failure of specimen is 44.00 joule. So that's all from us. Thank you for listening.